Okay, so in 14 we have a polynomial equation. They first ask us to use the rational zero theorem to list all potential rational zeros. So keep in mind your numbers on top, what we call the p-values, those come from factors of your constant. We don't worry about the negative sign because we're considering both positive and negative factors anyway. So all my factors of 25 would be a 1, a 5, and a 25. And then your factors of Q comes from your leading coefficient, the number in front of the highest power of x. So factors of 2 in that case are both 1 and 2. Now, you do have to go ahead and simplify. You take every number on top and you divide it by every number on bottom, again, making sure you've got that plus or minus in front. So I first just put everything over 1, and I got 1, 5, and 25. And then I came back and I simply put everything divided by 2. So 1 divided by 2 gave me a half. 5 divided by 2 gave me 5 halves. And 25 divided by 2 gave me 25 halves. Now, on this next step, we allow you to look at a graphing tool to get a starting point. And so I always suggest you look at the Desmos graphing calculator. You can just put that into a Google search, Desmos graphing calculator, and I just hand drew a picture of what I got right here. So you'll notice that I see 2 actual starting points. It was definitely crossing at -1, and it was definitely crossing at 5. So you have to have at least one starting point. So I'm going to pull the -1 first, and then put my coefficients out next to it, carry out my synthetic division. So I brought the 2 straight down. 2 times -1 is -2. I added them and I got -5. -5 times -1 is +5. I added and I got -25. -25 times -1 is +25, and when I added I got 0. And that's what I'm wanting to see. I should get 0 in that last column if that truly is a solution. So I know definitely x equal -1 is a solution. Now, I could, at that particular point, try to take my depressed polynomial and either factor it or use the quadratic formula. Remember that if this started as 2x cubed, once you've done synthetic division, this is now 2x squared, and that would be a minus 5x minus a 25. Or, if my graph did show me another definite, I can go back and do synthetic division again, but using my coefficients from the depressed polynomial. Don't go back to the original or you're just going to keep running in circles. So I went ahead and just did synthetic division again using those new depressed coefficients. Brought my 2 straight down. 2 times 5 is 10. When I added, -5 plus 10 gave me 5. 5 times 5 is 25. And again, this is what I like to see because that tells me I'm on the right track. So x equal 5 is also a solution. There was my -1, there's my 5. Taking what I have left over now, the 2 is now the coefficient of x since I've done synthetic division twice, and the 5 is now my constant. So I set it equal to 0, solve for x. And so in that case, my third solution ends up being x is -5 halves. And you should be able to see that on the graph as well when you're actually looking at it. But you do have to show me, you can't just read them straight from the graph and give me these answers. I've got to see this work, that you know how to get it once you have that particular starting point. Okay, so then on question 15, we've got a rational function going on here. And so with rational functions, we're going to first ask you about their asymptotes. For vertical asymptotes, remember you're going to take whatever's in the bottom and set it equal to 0 and solve it. So in this case, I get a vertical asymptote of x equal -6. For the horizontal asymptote, you're going to be looking at your highest powers of x on top and bottom. If the highest power of x is on bottom, like I've got in this case, I refer to it as bottom heavy. And in that case, you always get y equals 0 as your horizontal asymptote. If it were flip-flopped and the highest power of x was on top, you would tell me there's not a horizontal asymptote. And then if the highest power of x is the same on top and bottom, that's where you would take the ratio of their coefficients. And then finally, identified four ordered pairs. It's really up to you, whatever x's you want to plug in. Make it easy on yourself. So I did things like 1, 0, 2, and 3. You're just plugging them back into the original function and leave it in fraction form. So these were the four ordered pairs that I got. But again, it's really up to you. I think the only thing they want you to do is stay within positive 10 to negative 10. They don't want you to plug in huge numbers there.